Hi guys, welcome to my channel. This is Imaneo, and in this series we are implementing a color switch game replica using Flutter and Flame game engine. So in this episode we are going to add a scoring system, add some particle effects when you collect your scores and these kind of things. So let's get started. At first, let's take a look at the latest state of the game. As you see, we have a pause menu. We implemented it the previous episode, and we blurred the background and other things. And here we have our player. You can play with the game. And now let's make this one, the second circle rotator, a little bit challenging. I'm going to add another circle rotator around it. We can do it. What was that here? Generate components. I think this is this one. We are going to add another one at the same, exactly the same location, but with a different size. For example, let's test 200. It is too much. 180. Yeah, it's good. It's like a real game. So it is a little bit challenging. Now we need to add some stars at the center of these circle rotators. At first, let me open the icon finder website. We are going to find a star icon. We are going to get a free one. This one is cool. Also, this one is cool. I'm going to use this one. I think 256 is enough. We are going to change it to a star icon, and I'm going to add it in assets. Okay, now let me add a new component called StarComponent. And here we can say the StarComponent extends position component. And we have a sprite here, a star sprite. It is a late variable. We are going to implement the onload method, and here we have a async method here. Maybe we can await for the super here, wait at first. Then we are going to load the sprite that we are looking for. Let's see how we added the other one. Yeah, we just write the icon name. We can say star icon dot png. Yeah. Okay, and in the render method, we are going to render our sprite in the canvas. Let's have a required position and size here. We can say super.position, super.size. We can make it optional, but this one is required. Yeah, we can make the size optional. We can say it is a vector2 of 28 or something like that. Okay, so now we have size and position here. We can say we want to render this. Position is, I think we can say size divided by 2, and size is size, anchor is center. Also, this anchor is center. Now we can add this component to the game. Here when we are generating the color, the circle rotator, we can add a star component at the same location that we have the circle rotator. For example, yes, as you see, we have our circle here. Let's increase the size to see whether it is fully centered or not. Yeah, it seems it is fully centered. So 28 is good. And to change the color, we got familiar with the decorators in the previous episode. You can watch it if you haven't yet. We can add a decorator called, what was that? There was something for tint color. Yeah, we can use it like this. And we can color it white. Okay. Now we need to add hitbox. As you remember, hitbox is for when you want to have collision detection. For example, here we want to say if our player hits the star, we want to collect it and increase the score. To do that, I'm going to let's see what we did in the circle arc. If you remember, yeah, we added a hitbox like this. And here, for example, in unload, we can say add a circle hitbox, and radius is something like size.x divided by 2. Let me turn on the debug mode here to see whether it works or not. Yes, as you see, there is a circle around the star, and that is the collision detection hitbox. So let me turn off the debug mode. Now we need to change the player code. In the on collision, as you remember, we have some if-else logic to check the object or component that we are colliding with. And here we can say if other is a star component. At first, let's remove the other one. Remove from parent. And after that, we are going to increase the score or something like that. And if I run the app, as you see, when you hit the star, it disappears, and we need to add the score. Let's call a function on the game object. We can say increase score. And here, to implement this function, we need to have a variable, for example, current score, which is an integer, and then we can increase it whenever we call this function. The point is that we need to show it somewhere in the application, and in our main.dart file, we have some overlays. Maybe we can add a text here which shows our score. And this way, we need to have access to the property or variable that we are adding here from outside. That's why I'm going to use value notifier, I think. Yes, this way we can have a state that allows others to listen and update their state. For example, it can be value notifier, which has 0 by default. We can make it public, and here, for example, we can say value plus plus in increase score function, and then we can use it in the main function to show a score beside the pause menu. To do that, I'm going to wrap it with a row. Also, we are going to add a text, for example, 32. Font size is something like 24. Font weight is bold. Yes, it seems good. And now we need to show current score, that value here, but we need to rebuild this part of UI whenever this value is changed. To do that, we can wrap it with value listenable builder. It requires a listenable, which is mygame.currentScore, and a builder, which has, I think, context, value, and widget. And here we can return our text. Let's see what this builder has. Yes, context value and child. And it is an int value. We can use it here. And if I run the app, you see our score is 0. And when I collect the star, this value gets increased. But we need to reset the value when the game resets. Yes, here. We can say current score. What was that? Current score. Yeah, it is not private. Value is 0. And also let me add other star components. For example, we can add it here with the position of circle rotator. Okay, now we have 2 stars to collect. Let me check whether both of them work or not. Yes, everything seems good. Okay, the next step is to add some particle effects in the game when we collect the star. So to do that, at first I wanna change the color of this star to something like white. This way we can remove this decorator because it makes a code a little complicated. Okay, so we have the white icon here. And now I can remove this decorator. And if I run the game, yes, we have the white star here. And now we need to get familiar with the concept of particles. So particles is a way of adding some repetitive or producive effects. For example, I opened this Godot documentations because they have some visualized effects. Basically, particle works with a lot of minor things that they are called particle to show a complicated effect. As you see here, we have a bunch of stars which are moving away from a center point, and in most cases we have randomized values. For example, here, as you see, the stars are moving with a random value and with a lifetime duration. For example, they get disappeared after a while. And here we have, for example, direction particles. Here we have a spread. There are a lot of stars generating at a point and they are spreading with randomness. Yes, you can create a lot of cool effects using particles. Okay, now let's get back to the Flame particles. Flame has some tools to help us to generate our beautiful particles. We have a particle system component which has a particle parameter, and you can generate some particles to show in the game. For example, in our case, we want to show some particles when we collect the star. For example, we can disappear the main star and show some little particles, little star particles, which are moving slowly and hiding after a short time. To do that, for example, we can use we have some lifespan. Yes, it says how long your particle is alive, and after that it gets disappeared. So there are some built-in particles: translated particle, moving, accelerated, circle, image, and other things. To do that, let me remove other components to just focus on the star. For example, we can remove the color switcher, circle rotator. We only have stars, and now we can increase their count. We have it on 0 and 200, maybe 0 and 100, and we can have it on 0 and minus 100 and 0 as minus 200. Okay, this way you can collect all of them. Now we can say when we when we collect a star, we can show a particle. So to do that, I'm going to open the player. Here we can say if we collide with a star component, we remove it from parent and increase the star. Now we can say other.show collect effect, and we are going to remove it from here. And in this method, at first we remove this from the parent, and after that we are adding a particle. Let me copy paste this code here. Instead of game.add, we can say parent.add. We can do this before remove parent to be sure that parent exists. And let me move them here. Let me import it, and position should be the position of our star. Let's see what happens. You see, here we have a single circle particle which moves around. Okay, let's write our customized particle. We can say parent add a particle system component, and here we can pass a particle. So we have something like particle.generate, which has a count. For example, we can say count is 30, and we can implement the generator. It gives you the index, and you need to return a particle here. For example, we can use this one to see what happens. Okay, let's see what happens when I collect a star. Oh, let me comment this section. It has a wrong position. We need to say position is this position. And yes, we just create a circle here. Particles are composable. You can compose them together. For example, here we created an accelerated particle. Let's have it here. We can cut this one and have an accelerated particle, and child is a circle particle that we have. And here we need to define a speed, and also we have acceleration. I think let's define it by ourselves. We have a speed. We can say a speed is a random value, and our acceleration is a random value too. And let me run the yeah, as you see, we have a bunch of red circles which are moving away with the speed and acceleration. Now we can replace this circle particle with a sprite particle. Yes. Now here we can pass a sprite. Let's get this sprite. I think we have size. We can say size is this dot size divided by 8, for example. And let me run the yeah, as you see, we have some stars moving. Let's divide it by 4 to have larger stars. Okay, now we have our particle, which is not really cool. Let's increase the value, the size. Yes. I think we can add an effect to decrease the size of them and also rotating them when they are created. To add the rotate effect, we can wrap it with a rotating particle. Yes, child is this one. I think we can, from is 0 to is 2 times pi. I think it's good. Yes, but if we want to have some randomness, we can say 2 is next double, and we can time it by pi times 2. This way we have some randomness for the speed. Okay, and now we can add the effect to decrease the size of the stars when time goes. To do that, we have a computed particle. It gives you a renderer. You have access to, yeah, this is a particle. Let me find it. Yeah, this is a particle, and particle has a progress, and progress is something between 0 and 1. We can render our shape ourselves with opacity that we want. For example, we can say, here we want to have a computed particle and renderer. What was it? It was a canvas and particle. And here we can, instead of a sprite particle, we can render it by ourselves. We can say a star particle dot render on canvas, and we can say size is this one. We can define the anchor, maybe anchor dot center, and now we can have an override paint, which at first let me run the app to see what happens. We have the particles, but we are the one who renders the particle, so we have access to the other properties of the rendering. For example, we can override the paint with something like color is colors.white 10, for example. And if we run the app, as you see, we decrease the opacity. But we want to have something that works with particle.progress. So to do that, we need to say we want to have colors.white with opacity, and opacity is -1 particle.progress. So this way we have disappearing particles. Okay, and what if we decrease the size too? For example, now we just decrease the opacity, but we can decrease the size using the progress here. For example, we can say this value times particle.progress, and something vice versa. We can say -1 of progress. I mean, progress is 0 to 1, but when we say 1 minus progress, it means 0 to 1. 1 to 0. Yes. And we have a lifespan here. We can increase it to 1 to have a better duration for them. And yeah, that's it. We can maybe decrease this value to 80 maybe. Yeah, that's fine. You know how satisfying is that when you collect the star? Yeah. So let me remove this code and show collect effect. We need this function. We are calling it to remove the star from parent and add the particles. And also let's revert the code that we commented in our my game. Okay, this is the normal state of the game, and when you hit the star, some particles are generating, but I realized an issue here. Particles are generating on top of the player. In our game, player should be on top of everything. To do that, we can change something here. We have priority. Yes, we have priority, and we can change the priority to something like 20. It tells the flame that we want to draw this component on top of everything with this priority. And because in our game we have lower priority for other components, 20 means that on top of everything. Yes, now player is on top of anything. Okay, thanks for watching this video. If you like it, don't forget to hit the like and subscribe button. And in the next episode, we are going to work with some cool sound effects and background music. For example, when you collect a star, we are going to play a sound effect, a satisfying sound effect. And yeah, so stay tuned for the next episode. See you. Bye bye.